Chapter 1 Examples 1.10 to 1.18 related to exercise number 1.4 are in this video. First, we go through example 1.10. Using vertical line test, determine which of the following curves 1.18a, b, c, d represent a function. So, actually, we have four graphical representation of curves. We have to check which are all functions and which are not functions. First, we consider the figure 1.18a. Vertical line test is to be used. That means draw a vertical line uh, which is perpendicular to x-axis. It means in this line x value is fixed and y value is changing. For single x, there are many y value. If the curve intersects this vertical line at more than one point, it means a single x is having many y values. It means it's not a function. Uh, Either the vertical line we draw may intersect at one point or even do not intersect. That if it intersects at more than one point, the meaning is the given curve is not a function. So first example 1.1a, 1.18a is not a function. Second, 1.18b, we have a parabola and draw a vertical line again. This vertical line cuts exactly the curve at a single point. So this is a function. But in third figure 1.18c, you please go through the textbook. That's also a parabola, but the vertical line touches the parabola at 2 points. So the point of intersections are 2, therefore this is not a function. In the last one, fourth figure, it is 1.18d. It's also intersect the vertical line at a single point, therefore this curve represents a function. So out of this four examples, 1.18a and c are not functions and the remaining two, that is b and d, are functions. Next example 1.11. Problem is, let a equal to 1, 2, 3, 4 and b equal to 2, 5, 8, 11, 14 be two sets. Let f is from a to b be a function given by f of x equal to 3x minus 1. Represent this function. Subdivision 1 is by order diagram, subdivision 2 in table form, subdivision 3 as a set of ordered pairs, and fourth subdivision is in a graphical form. So we have to represent the function. So solution part, first we write a and b and also f of x. After writing f of x, which is 3x minus 1, we have to write each of the value, f of 1, f of 2 and f of 3. The last one is f of 4 using the function f of 3x minus 1. So f of 1 means 3 into 1 minus 1, which is 2. So finding all those values, arrow diagram format is the first subdivision. For that, we first take A and B and write in the pictorial format. 1, 2, 3, 4 are the elements of A, and B contains 2, 5, 8, 11, 14. Later, we connect each element from A to the respective image f of value. 1 is connected to 2, 2 is connected to 5, 3 is connected to 8, and 4 is mapped to 11. This is the order diagram for given function. Second subdivision is to write in a table form. That means we have to just draw a table which contains first row as x values and second row as f of x values. This is the table form. Second subdivision, x values 1, 2, 3, 4, corresponding f of x values which are obtained in the first part of the solution. In the beginning, we write the respective values 2, 5, 8, 11. So table form is completed. Third subdivision is set of ordered pairs. So we write f function f as set of ordered pairs. That means using set brackets, Within that, we write each of the ordered pair, each element of set A and corresponding image are separated by commas and written as a ordered pair. So 1 comma 2, 2 comma 5, 3 comma 8 and 4 comma 11 are the elements of F. We give this a set of ordered pairs. Last, fourth subdivision is graphical form. Graphical form means we just take all those 4 points and plot that points in the xy plane and then connect all those points. We get the graphical form. Hence, example 1.11 is completed. Now example 1.12. Problem is using horizontal line test figure 1.35a, 35b, 35c. Determine which of the following functions are 1 to 1. There are three graphs. Previously we did vertical line test. Here horizontal line test. First we should know the meaning of horizontal line test. If we draw a line, horizontal line to x-axis, then throughout that line y value is fixed and x values are changing. That is, for a single y there are many x. It means that function is not uh, one to one if the particular curve of the function intersects this parallel line, horizontal line, at more than one point. This is the meaning. So if we take first curve 1.35a and draw a horizontal line, it exactly cuts at a single point. Therefore, it's a 1 1 function. That means for a single x, for a single y, uh, single x is existing as an pre-image. For figure 1.35b, this curve cuts at two more than not only two more than one point at the horizontal line. Therefore, this is not one to one. And the third example, the curve and the horizontal line exactly meet at one point. Therefore, that is one to one. So out of these three figures, A and C are one-to-one function, and the middle one, that is B, is not a one-to-one function. Next, example 1.13. Let A equal to 1, 2, 3, B equal to 4, 5, 6, 7, and F is set of all ordered pairs 1, comma 4, 2, comma 5, 3, comma 6. Be a function from A to B. Show that F is one to one but not on the function. First, we list out A, B, F in the first line of the solution. Then, draw the arrow diagram for this function F. That is, pictorial representation of A and B are given, and then by each element of the function f, we just connect the respective elements from A to B. After mapping or connecting these elements, we have a complete arrow diagram, and from the arrow diagram, we can easily decide this function is one to one or onto. Just checking each of the element in A has individual separate elements as a separate image. Therefore, this is one-to-one function. But in the reverse case, if we take the codomain, uh, 7 is having no pre-image. Therefore, this is not onto. For onto condition, every element of the codomain should have pre-image, but 7 is not satisfying the condition. Therefore, this is not onto. But it is one-to-one because different element of A have different images. Hence, we give the conclusion f is one to one but not onto function. Example 1.14. If set A equal to minus 2, minus 1, 0, 1, 2 and f is from A to B is an onto function defined by f of x equal to x square plus x plus 1, then find B. Here one set is given, function is also given, but we have to find the second set B, codomain. First we write A and f of x. Then for each element A, we have to find f of the corresponding elements, f of value, function value. So f of minus 2, we take a function x square plus x plus 1. Instead of x, we just enter minus 2. So f of minus 2 is finally 3. Similarly, for each element in A, we find the respective images. After completing those steps, we just collect all those elements, that is f values, and write it as the codomain 137. So f of 0 is 1, f of minus 1 is also 1, but there is no need to repeatedly write 1 in B because a single element has more than one pre-image. Therefore, finally, we write those collection 137 as set B, that is codomain for this function. 1.15 problem. First, we read the example. Let f be a function f from natural numbers to natural numbers be defined by f of x equal to 3x plus 2, where x belongs to n. Subdivision 1, find the images of 1 to 3. Subdivision 2, find the pre-images of 29 and 53. Third subdivision is identify the type of function. Here, f is a function, and from natural numbers to natural numbers, f of x is also given. We have to first find images for 1 to 3. Second, pre-images for 29 and 53. Third part is to identify the type of the function. For this purpose of finding images, we should take x value as 1 and f of 1 value is now obtained by substituting x equal to 1 in the function, that is 3x plus 2. So 3 into 1 plus 2, which is 5. Similarly, for x equal to 2, the image is 8, and x equal to 3, image is 11. Image means just entering the x value in given function f of x equal to 3x plus 2. That is, instead of x, we just enter this values. The corresponding f of value is identified, and they are the images. So first part is completed. Second, for pre-image, we have 3x plus 2 as 29 here. We should find x value in the reverse process. So solving that equation, x value is identified, which is 9. Similarly, 3x plus 2 is taken as 53, and the corresponding x value is identified, which is 17 here. Therefore, the pre-images of 29 and 53 are 9 and 17 respectively. So after completing the second part, now come to the third. We have to identify the type of function. Here, domain and codomain are natural numbers. So as per our calculations, the range, that means the images of the domain 1, 2, 3, etc. natural numbers are calculated, and sequentially if we listing that images 5, comma 8, comma 11, comma etc. That set is actually the range because they are images, collection of images, and it is a proper subset of the natural numbers. Therefore, this uh, particular function, given function, definitely is not onto, but it is one to one because individual elements, different elements have different images. Uh, More than one elements have no common image. Therefore, this given function is one-to-one function, but it is not onto. So we complete 1.15. This is 1.16 example. We read the problem first. Forensic scientists can determine the height in centimeter of a person based on the length of the thigh bone. They usually do so using the function h of b equal to 2.47b plus 54.10, where b is the length of the thigh bone. Subdivision 1, verify the function h is 1 to 1 or not. Second, also find the height of a person if the length of his thigh bone is 50 centimeter. Third subdivision is find the length of the thigh bone if the height of a person is 147.96 centimeter. See, this is also a function, but related entries here are, one is height and another one is thigh bone length. They are respectively denoted as H and B. A person's height and thigh bone length are connected and given as a function. Usually, notations F and X are familiar to us. Here, just name of the variables in the function only different. But given relation H of B is uh, taken directly in the first line, we have to first prove this is one to one. That is the first subdivision. uh, Prove, not only not prove, we have to check this one is one to one or not. Let us consider the images for different elements are equal. That is h of b1 equal to h of b2. According to the function definition, h of b1 means 2.47 b1 plus 54.10 equal to 2.47 b2 plus 54.10. After simplification, we get b1 equal to b2. So if two images are equal, and then the respective elements also equal, this means given function is one to one. This is the procedure to uh, prove given one is one to one function in general. If the images are not equal, we can conclude that that is not one to one. But here, h of b1 equal to h of b2 assumption gives b1 equal to b2. Therefore, this function is one to one. Next, second subdivision is uh, we have to find the height, and given quantity is thigh bone, which is 50 centimeter. B is given, H is going to be calculated. So H of 50 equal to, instead of B, we write 50. So that the answer here is 177.6 centimeter. So for a man with 50 thigh bone, 50 quantity, the corresponding height of the person is 177.6 centimeter. Third subdivision is we have to find thigh bone length, and height of the person is given as 147.96. So in the same equation, uh, in the same h of b function, we have to write height here. That is 2.47b plus 54.10 is 147.96. That is, instead of h, we write this height, so that we can find b. B is the bone length. So it is calculated, which is 38 centimeter. Hence, all the three subdivisions of example 1.16 are calculated, completed. Next example is 1.17. Let f be a function from R to R defined by f of x equal to 3x minus 5. Find the values of a and b given that a comma 4 and 1 comma b belong to f. Given function, we directly write f of x is 3x minus 5. This can be written as f equal to set of all x comma 3x minus 5, where x belongs to real numbers, because as per the first line of the problem, f is a function from R to R. Therefore x belongs to R, we write here, and the function value is given as the second element of the ordered pair. We have to find the values of a and b if a4, a comma 4 and 1 comma b belong to f. That is, just treating a comma 4 as an element of f and find the value of a. Similarly, 1 comma b is taken as an element of b. We should find the value of b. A comma 4 is an element of f means the image of a is 4. That is, f of a is 4. F of a is nothing but 3x minus 5, where x is equal to a. So 3a minus 5 equal to 4, which gives the value of a equal to 3. Similarly, 1 comma b is an element of f means 1 is the image of b. So f of 1 equal to b. F of 1 is 3 into 1 minus 5 equal to b, which gives you b equal to minus 2. Hence we find a and b. Example 1.28. Problem is if the function f from R to R is defined by f of x equal to 2x plus 7 where x less than minus 2. It is x square minus 2 when minus 2 less than or equal to x less than 3. It is 3x minus 2 when x greater than or equal to 3. Subdivision. Then find the values of subdivision 1 is f of 4, subdivision 2 f of minus 2. Third subdivision is f of 4 plus 2 into f of 1. Fourth subdivision is f of 1 minus 3 into f of 4 by f of minus 3. Solution part. Actually, here the function is a piecewise function. It is not defined as a single entry for the whole interval. It is subdivided into three portions. So for each of the case given in figure 1.39, you can go through the textbook. In the real line, there are three interval parts here mentioned, and each of the part contains different f values. First, we draw this line. Now we consider the first subdivision f of 4 value. 4 is actually, first we check in which this break, in which interval portion 4 exists. If we check it, it is the third part, that is x greater than or equal to 3 contains 4. Therefore, f value, corresponding f value is 3x minus 2. Hence, f of 4 is 3 into 4 minus 2, which is equal to 10. Second subdivision, x equal to minus 2, which lies in the middle part, that is minus 2 to 3 case. Hence, the corresponding f value is x square minus 2, which is equal to minus 2 the whole square minus 2. The answer is 2. The third part is f of 4. F of 4 already, f of 4 plus 2 f of 1. F of 4 is actually obtained from step subdivision 1. Using that, we find the total value f of 1, where 1 is lying in the middle portion. So f of 1 value is obtained using the function value x square minus 2, which is minus 1. So later, using subdivision 1 and the current value, f of 4 plus 2 f of 1 is obtained as 8. The last fourth subdivision, uh, the part we have to find is f of 1 minus 3 into f of 4 by f of minus 3. F of 1 as well as f of 4 already we have, and now f of minus 3 we have to find. Minus 3 is in the top range, that is x less than minus 2 case. So the function value is 2x plus 7. Hence f of minus 3 is obtained. It is 1. Using all those values, given part is completed. Fourth subdivision, f of 1 minus 3 into f of 4 by f of minus 3 is calculated, and it is minus 31. So using all those subdivision parts, almost we use all the parts for each of the subdivision, and all the four subdivisions answers are obtained.